I'm the Coffee Crow, and in this video we'll be creating an intermediate 2D player controller. This is a more expanded version of the controller I made in a separate video. If you haven't seen that and want to learn the basics, I recommend you go check that out. It's really useful to kind of learn simple stuff before you dive into something intermediate. Anyway, we'll be using OOP concepts to build out a player controller that will give us some finer movement with acceleration, deceleration, and double jumping. One of the best things about learning how this is created is you'll be able to take parts of this controller and use it for different things, so you won't have to rewrite the same code over and over and over. Kind of like how you build things out of building blocks. Now, let's move into the editor and actually start putting it together. Now we are in our editor, we have a few things to set up. The first of which will be our game manager. So we're going to create a new folder. This is going to be for auto loads, so our singletons. And in here, we're going to create a new script. We're just going to call this game manager. Now, it's always good to have a auto load that does manage a lot of different pieces in the game. This specifically, just for now, will be handling our gravity. So we're going to create a new const. It's going to be called gravity. It's going to be set as a float, and we're going to just set it equal to 1000. The last part of actually setting this up is going to be a function. We are going to want to put the function for applying gravity in here, so any other physics-based node can actually use this function to apply gravity to itself. So we're going to write func apply underscore gravity, and to kind of make this usable by everything, we're going to pass in the parameters entity and then character body 2D. Now, you can name the entity part whatever you want. I prefer entity, it just makes life a bit more understandable for me. We're going to also pass in one more parameter, and that's just going to be for our delta. We're going to type that as a float. This will have a void return type, and inside of it, all we're going to type is entity.velocity.y plus equals gravity times delta. Now, that's the game manager setup. We don't actually need to do anything more with this throughout the rest of the project. So the next thing we want to actually move on to will be kind of modifying our player and actually getting our player set up. But we also want to go into our project settings, go to our input map, and give it the basic inputs that we want, which in this case will be move left, move underscore right, and jump. Now we're going to set up the actual keys for these. Move left will be A and left arrow key. Move right will be D and the right arrow key. And we'll set jump to space and W. You can also do up arrow key. There we go. Now with those two things out of the way, let's actually move into setting up our player. So for our player, we're going to be creating a new scene of type character body 2D. You'll see here I've already got it set up and saved. I've also got it placed into a group for camera related reasons. But for now, this is all you need, is just a player, the character body 2D. Now we need to add our sprite, our collision shape, our animation player, and if you haven't set up a separate camera, you can just add a game camera to this. So you can just add a camera 2D, and that'll be fine. Change it to zoom as a 2. I've already got this set up in our main scene, so I won't be needing that for now. So let's go and get our sprite and our collision shape set up real quick. I'm going to scroll in so we can actually see the sprite. I'm going to go down into characters, set the character sprite to this. I'm once again using the Kenny 2D asset packs for platformers. Absolutely great. Once again, always in the description. Go check them out. I need to go into our offset, set the flip H, set this to -12 to make sure that the pivot point is at the feet for some animations. Now we can go and set up our collision shape. I'm going to be using a circle. You'll notice I tend to always use circles unless certain instances where a capsule would be better, but for now, circle will be fine. It's always set up at the player's feet as well, because that's the place we actually want connected to the ground, whereas we want the head to be able to kind of clip a bit easier. I'm going to hit Control S to save. Now we are going to add a script into our player. just going to be called player. We're going to add a class name, class underscore name to our player. I'm going to be calling the player entity. I can spell, there we go. And unlike the previous video, we don't actually need many things in our player script. We're going to be needing our sprite and our animation player. I'm going to typecast these as a sprite 2D and the animation player as animation player. Animation, I can't spell. There we go. Now, with those set up, we can actually start moving on to the more the OOP concept of this, where what we're going to be doing is building out individual customized nodes that will allow us to kind of reuse them for many different types of entities or many different types of players or entities in general, like monsters, for instance. So to do that, we're going to add a new scene. We're going to make it of other node 2D. This is just going to be of node. This one's going to be called our input underscore handler. And all it's going to do is handle our inputs. So let's save this under scenes. I'm going to save it into the handlers folder. Then add a script to it. We are once again, we want to give this a class name of input handler. Now, for our input handler, we don't really need to be doing much, and there's a reason why I like to have this as its own node, because having the ability to modify different inputs or add extra inputs and then just keep it in one node allows you to really easily customize it and, well, find where it is if you need to actually modify it. So let's go and set up our basic left and right input. We're going to write func get underscore left, or get input underscore left underscore right. It's going to take no extra parameters, but it will return a float. Now, I said this in the previous video, but I'll reiterate again. We want it to return as a float because if we use input.get underscore axis, then we set move left and then move right, this will return a float based off of which button we press. Move left is a -1, nothing is 0, and move right is +1. This just kind of makes it a lot easier when checking for buttons, condenses it down a little bit. With that one done, we want to handle our jumping finally. So let's go func get underscore input underscore jump. No parameters, and this time it will have the type of bool. All we want to check is if our input is, or if jump is actually being pressed. So we're going to type return input.is underscore action just pressed jump. Now this is our input handler sorted. Now this isn't the best example for kind of building blocks, but you could use this for, I don't know, say you're creating a game with a car or a horse or something that your character can kind of use. You would be able to apply this to make sure that specific entity has the ability to actually gain inputs. So to get this to actually work, you need to go into our player, left click on our player, hit Control-Shift-A to instantiate a child, and then we're just going to add our input handler. Now, I like to have my handlers above the animation player in a kind of certain order. You can kind of order it however you choose. You'll notice that I have a specific order for mine. Now we need to go back into our player and we need to add an onReady variable to our player. Now I didn't explain this before, but the way I'm doing this is left click drag, control, drop. Typecast it as an input handler. And that's it, that's our input handler set up and ready. Let's now move on to actually giving our character the ability to move left and right. We've figured out the inputs, we just need to actually apply those somehow. So we're going to do the same thing we did last time. We're going to create a new scene. This is going to be of a 2D or node 2D type. We're going to rename this to movement underscore handler. We're going to save it into the handlers folder and we're going to give it a new script. Now, for a lot of my different types of nodes that I like to use, I always like to give them class names. You don't have to give them class names for typecasting, but I prefer it. I like autocorrect, or IntelliSense, basically. So we've got it typecasted or set as a movement handler. That's its class name. We now need to set up a few different variables. All of them are going to be exports, because having the ability to edit them in the editor is actually really nice compared to having them, like having to go back through the code and modify the code every time. So we're going to type export var movement underscore speed. It's going to be typecasted as a float, and it's going to equal 150.0. The next one is our exported var for acceleration. Once again, typecasted as a float. We'll call this acceleration underscore speed. Typecast as a float and set it equal to 10. And finally, we want one more exported var for deceleration underscore speed. Set this as a float and set it equal to 15. Now, these are the numbers that I feel are the smoothest for how I like things. Feel free to change these. As I said, you'll be able to change them in the editor up here. Now, moving on, we actually need to set up our functionality for handling our movement or our logic. So we're going to write func handle underscore movement. This will have a void return type. Now, this is where things can get either extremely coupled or very decoupled, depending on how you want to set it up. I want to have this movement handler to be able to be used not just by the player, but by other enemies too. Now, the easiest way of setting it so it can only be used by the player is by passing in an entity or player and then typecasting this as player entity. I don't want to do that. I want to be able to have enemies that can use this as well. So I'm just going to pass in an entity of type character body 2D. That allows me to pass in whichever entity I choose and not have it set specifically. Now we're going to need a movement underscore direction. We're going to typecast this as a float. And finally, we want to pass in our delta. Typecast that as a float as well. So setting it up like this really does keep it decoupled. The ways that you could set this so it's primarily only for the player, you pass in the player as a player entity, and then you pass in specifically the movement handler of type movement handler. That way only things with a movement handler, not a movement handler, sorry, an input handler can use this. But we don't want that. We want it decoupled and ready to use by other things. So we need to first check if our movement underscore direction is less than 0. If it's less than 0, we want to type in our entity dot velocity dot y, or dot x, sorry, equals. Now this is where things are going to be different from the previous video. The previous video I just hard set to negative movement speed. We actually want to use linear interpolation, which will give us this kind of build up for our speed and our slowdown, so our acceleration and deceleration. To do that, we type lerp. Then we first set what variable we want to change. So this will be the velocity dot x for our entity. Then we pass in what we want it to go to. We want movement speed, our maximum movement speed, so 150. And then finally, we need to pass in our acceleration speed, and then times that by delta to keep it frame locked. And that is just the movement direction sorted in one direction. So I'm going to copy this, then I'm going to paste it in. I'm going to change the less than symbol to a greater than symbol. I'm going to go back up to our original one, change that to a minus, and that handles our entire movement. Now, we're going to create one more if check here, and it's just going to be if movement direction is equal to 0, we want to do something. In this case, we want to do some deceleration and make it so our player slows down gradually. So we're going to create a new function for this, and we're going to call it handle underscore deceleration. All this is going to take is an entity typed as a character body 2D, and a delta typecasted as a float. It's going to be a void return type. And now we just have to handle deceleration. We can do the same thing with lerp. So we can write entity.velocity.x equals lerp. And then we set our entity.velocity.x to move toward 0.0, so hard stop. We're going to use deceleration speed as our weight. We're going to times that by delta. Now, this is the movement handler kind of setup. We do need to make sure that we pass in handle deceleration where our direction equals 0. And then we want to pass in entity and delta, like so. Now, as I said before, we can now use this for multiple different things, not just the player. Question is, how do we get this to work on the player? So let's go back to our player. Let's click on our player's root body, hit Control-Shift-A to add a movement handler. I'm going to put this below the input handler. Go into the player script, drag in our movement handler, keep these separated, make it easier to see, typecast it as a movement handler. And now we want to go func underscore physics process and pull up our physics process. This is where things are going to be actually applied to our character, right? Now I'm going to type pass. I'm going to go back into main under entity, and you can see here that I've already got the player under a specific container, which is right here. I'm going to hit F5 to play and see what happens. Right now, nothing, because nothing is happening in our physics process, right? So let's first sort this out by adding our game manager to our auto loads. Like so. Click add, and that's set up. Now, in our physics process, so we want to call our game manager and then call apply gravity, and then pass in self and delta. Now, before this will function, we need to call move and slide on our character. Reason for that is this is the trigger. This is the, okay, I want you to apply physics or the movement that I want you to from our velocity to our character. So now let's press F5 again and see that our character now falls to the floor. Perfect, working. Everything we want. Now let's get movement actually functioning. The first thing I'm going to do, just above move and slide, is type velocity dot normalized. Now this is primarily here just to set up for moving and jumping around. It basically makes it so when you're moving in a diagonal, it is normalized and not kind of multiplicative. In some games you'll see that if you're moving up and to the right, you move faster than if you were to just move to the right or just move up. Normalizing it stops that from happening. So let's now type in movement handler dot handle movement, pass in self. Now here's where it gets a bit fun. We pass in our input handler dot get input left and right, and then we pass in our delta. Now let's press F5 and give this a test. You can see our character is moving, and if you pay very close attention, there is a slight warm-up to our character getting to top speed, and if I release, it slowly comes to a stop. It feels good. It doesn't feel as snappy, which can be really nice sometimes depending on the game you're creating. Now, if you're creating a precision, like pixel platform or a really hard game, this might not be for you. But if that's the case, you can go to the movement handler and you can change these. So say you want to come to a stop faster, you could change the deceleration speed to, let's say, 25, hit F5, and now the character comes to a more precise stop, right? And the same with the acceleration speed. If you wanted your character to kind of move from walking to running or idle walking running, you could change the acceleration speed down to, say, 5. And your character will slowly speed up to that correct amount. I forgot to hit enter. There we go. Try that again. You can see it takes a good second for our character to hit max speed. I'm going to change these back to what they were. that sorts out our movement handler. The next thing we want to do is handle our jumping and actually give our character the ability to jump, and in this case, double jump. For our jump handler, we're going to do the same thing we did before. I'm going to come up here, new scene, new 2D scene. Going to call this jump underscore handler. We're going to save it into the handlers folder. Going to create a new script and add a new script to it. Give it its class underscore name of jump handler. Now, we need to create a few variables. We need to create a exported var for our jump underscore speed. Going to set this to a float, and we're going to set this equal to -400. I explained this in the last video, I'll explain it again. Negative values is up in Godot, so we want to move up, we need to use negative. You can use this here, or you can use this in the code. We'll write in a few minutes. So the next one will be a variable, an exported variable for our full underscore speed. Typecast this as a float and set this equal to +400. And then finally, we want to set our exported var and set a max underscore jumps, because we want our character to be able to double jump. So we typecast it as an int, and I'm going to just set this to 2 for now. Now, we're going to need some more internal variables that aren't exported. The first one will be a variable for our current underscore jumps underscore remaining. Set this as an int and set it equal to 0. And finally, one more variable for has underscore jumped. We're going to set this as a bool, and we're going to set this equal to false. Now, the reason why we set this to 0 is you can set it to 2 immediately. Sometimes it's just better to just set it in the ready function, like so, ready, and then set current jumps equal to max jumps. This way we're always getting the maximum amount of jumps. Say you're creating a roguelike as a roguelike platformer. This will allow you to have a variable amount of max jumps, and every time your character actually loads into a scene, it now gets that new version of max jumps. So if you have an item that increases it, you always have that actually applied. Kind of what we want. Perfect. Now, let's create a new function. This is going to be for handling our jump. So handle jump. We're going to do somewhat of the same thing as the movement handler. I'm going to pass in an entity as a character body 2D. And then we're going to do jump underscore pressed as a bool. This will have a void return type. And for now, we're going to hit pass. Now, you could say you wanted to create a frog enemy, right? You may want to change this so it's not going to be linked to the input handler. In this place, I'm going to be using the input handler as linking it to the jump. But you could create a different type of script that will toggle a certain variable, or like a bool, for pressing a jump or is jumping, and then passes it in like that. So to actually handle our jump, the first thing we need to do is check, and now this is going to be a bit confusing, we want to check if our entity is not. So if not, entity.is on floor. I know that's a little bit confusing. We're basically going, is the entity, whatever this entity may be, is it on the floor, yes or no? And if it's not, this is going to evaluate what we want it to. And has jumped equals false. If this is the case, we want to just return out of the statement. Now, what this is going to do is handle, if we walk off of a ledge, we don't want our character to immediately be able to jump. If you do want your character to be able to jump after they fall off of a ledge and before they actually land on the floor, then you can remove this if you want to. Personally, I like this. So with this done, let's now actually do our check to kind of reset our jumps. So we're going to go if current jumps, or sorry, we're going to check if our entity is on floor. So if it is actually on the floor, we're going to go set this to true. We're going to check if it's true. And then we're going to go current jumps remaining equals max jumps. And then finally, we want to set has jumped equal to false. Now, all this is going to do is reset our maximum jump amount when we actually land and touch the floor so we can jump again. Now, let's actually handle the jumping logic. We're going to write if jump pressed equals true and current jumps remaining is greater than 0, we're first going to want to go has jumped equals true, so we now have a boolean representing if we have or have not jumped, which is being toggled in a few different places. Then we want to take our current jumps and then a minus equals 1 to remove one of our jumps. Now we want to actually allow our entity dot velocity dot y to increase by our jump speed. And that will mostly be it. For the next part, we're going to want to actually handle our falling, right? We're going to create a new function for this, handle underscore fall. It's going to just take an entity of type character body 2D, have a void return, and in here we need to first check if our entity dot is on floor, not is on ceiling, is on floor, equals false. Now you could do what I did up here where you type not instead of setting it to equals. This is the same thing, different keyword. Well, mostly same thing. There are a few minor differences. For now, I'm going to just use the equal to false and has underscore jumped is equal to true. So in this case, this is saying, okay, you have jumped, you are no longer on the floor, what should I do? We're going to use clamping, so clamp F. Now this is going to take 3 different variables. The variable we actually want to affect a minimum and maximum, like amount. So we want our velocity, entity dot velocity dot y. We want our jump speed, and we want our fall speed. Now, at the very end of us pressing jump, we want to actually handle our fall and pass in our entity. Now, this should be our jump handler pretty much set up and sorted. Let's go and move back into our player. Click on the player, Control-Shift-A to instantiate a new child. We're going to instantiate the jump handler. Move this about, create an onReady variable for it, typecast it as a jump handler. Now we want to actually call its functionality. So we're going to write jump handler dot handle jump. We need to pass in our self, and then we want to pass in once again our input handler dot get input jump. Now, let's go and give this a little test and make sure it's functioning. It's always good to test after you set up something new. So we're moving left and right, and we are jumping. Now, if this feels a little bit floaty, which to me it feels a little bit floaty, we can adjust certain things, i.e. we can adjust the gravity amount, the full speeds, well, pretty much anything we've set up. It's one of the best parts about this. And you can see I can double jump, but if I keep pressing space or W or the up arrow key, I can only jump twice. Now let's see what happens if I fall off. I can't jump anymore. So that's jumping, falling, pressing spacebar, nothing. Perfect, exactly how I want it to be. Now, there are a few things that we're missing, specifically 2 things. We want our character to flip, and we want something to handle some animations. So the first thing we'll do is go and set up the flip handler. So to start with our flip handler, we're going to do the same thing we've done with other handlers. We're going to create a new scene. This is going to be of type node. We're going to name this flip underscore handler. We're going to save this under handlers and give it a new script. I'm going to do the same thing I always do, class name, flip handler. Now, this is going to only have one function, and there's a reason why I set this specifically to just a node. Normal node types, i.e. not Node2D, just normal flat node types, require less resources to use, and certain nodes that will get reused a lot might actually be very beneficial to have as a node. So in this case, the flip handler, which would be applied to anything that moves, will be used a lot. So we want to make sure it doesn't require as much resource. So to set this up, we want to create a func for handle our flip. We're going to pass in an entity as a character body. And we're going to want to pass in a sprite. Now, there are a few different ways to flip your characters. Void. There we go. Pass. I'll explain this real quick. So what I'm doing is just specifically using the flip H functionality to flip the sprite. The other way of doing this, say you have many sprites all kind of on top of each other and you're using a more segmented way of animating, where you animate individual limbs and things like that, it might be a bit hard to just flip one sprite. So, and say you have 2 legs, 2 arms, a weapon, a head, and a torso, you would have to pass in all of those as sprites. Or, the other thing you could do is you could pass in a Node2D, and then, let me go to our player here. You would basically encapsulate all of your sprites within a Node2D, and then you would just change that Node2D scale to reverse. That way you're not actually changing the scale of the player or the character body. That can cause some major problems and will break. And you don't have to pass in everything all at once. I will probably go into that a lot later into either more complex video or something to do with animating, which sounds quite fun. For now, we just need to flip one specific sprite. So what we need to do is we need to check if our entities dot velocity dot x is greater than 0. Now, I've said this in the past, I'll say it again. Depending on which looking direction your sprite starts out in, will depend on how you set these. So for me, my sprite starts looking out left. I want it to always start looking out right. So I need to set my sprite dot flip H equal true. And then I need to reverse this if entity dot velocity dot x is less than 0, sprite dot flip H equals false. So if you have a sprite that's always looking right without you actually having to flip it, you would reverse these. Just a little thing you may get caught up on. So moving forward, the last thing we need to do is create an animation handler. Let's go and add our flip handler first. Control Shift A, then go down into our flip handler, put this just below the jump handler, create a variable for it, type it as flip handler. Now, quick order of operations thing, you want anything that will basically apply flipping, or anything that needs a specific variable after, to run after the variable. In this case, we are running our flips based off of our velocity. Our velocity gets modified after move and slide. So in this case, we want to call our flip handler dot handle flip after move and slide. We're going to pass in self, and then our sprite2D. Now, once again, let's go make sure this functions, give it a test. Our character is flipping, jumping, and double jumping, and feels smooth. I like it. Now, the final one is, as I said, is the animation handler. I like setting up animation handlers to be used across every node. It really helps with not having to write this code out, to be honest with you. This is where some laziness can kind of kick in. So to do this, we're going to go new node, other node, of node type node. Call this the animation underscore handler. Hit save. Give it a new script. Give it a class underscore name of animation underscore handler, like that. Now for the animation handler, we want to, this is where things can get a bit kind of funky. There are certain things you can do to make it less so. by setting up specific variables, but it really depends on how you name your animations. So let's create the function first. So handle underscore animations. We're going to want to pass in an entity and then a character body 2D, or as a character, not a callable, as a character body 2D. Then we're going to want to pass in an animation underscore player, typed as an animation I can never spell animation player. There we go. And we'll give it a void return type and hit pass. Now, the reason why I say it depends on how you name your animations, setting up an animation handler like this means you have to kind of stick to specific naming conventions for your animations, which can be a pain in the butt. Typos happen, things can break. But if you're 100% set and sure on what you like to name things, this will be fine. So I'll show you what I mean as we go. First thing we want to check is if our entity.velocity is equal to a vector2.0, meaning it's not running left and right and it's not jumping or falling. We want our animation player dot play to play the idle animation. Now this is exactly what I mean. If you don't name your idle animation idle, or you typo, give it a capital, get the LE backwards, it can be a pain to figure out where things are going wrong. The best part is debugger will tell you. But if you do have strict naming conventions, this will work. So the next thing we check is if our entity.velocity.x is not equal to 0, and our entity.velocity.y is equal to 0. So we are moving left and right, but we are not jumping or falling. We want our animation player dot play to play our move animation. This is another animation name that can be a bit funky. We could call this run, we could call this move, we could call this walk. It really depends on what you're going for. There are some ways around this. You could set up constant variables up here that you could change and it will change them for you. You could set out exported variables. A lot of different things you can do. You could help set up a signal bus to actually handle this stuff for you, which is a bit more complex, and I'll probably move into that at some other point. So the next thing we want to set up is our if entity.velocity, not visual shader node, no, velocity.y is less than 0, meaning we are jumping. We want our animation player dot play. We want it to play the jump animation. And then if entity.velocity.y is more than 0, which means we are falling, we want it to play the fall animation. Now, keep in mind what I said about this. It can be a bit funny. That's the last time I'll give a warning about it. So to do this, we need to go back into our player, to our player script and our player scene. We need to instantiate our animation handler, put it above the animation player, create a variable for it, typecast it as an animation handler, and then after we're flipping, we want to go animation player, animation handler dot handle animations. We want to pass in our self and our animation player. Now, I'm going to hit play, and you'll see that I don't have anything set up. And if you look at the very bottom there, the debugger's having a heart attack over the missing animations. So this is one of the benefits of just having a debugger, I guess. Like knowing that specific animations aren't working is useful, and it'll tell you which ones are missing. So if you know you've set them up, and then you're getting an error, probably typoed. So to get this to function, I'm going to go and create some animations. I'm going to probably do a speed up of this, so you don't have to sit and watch the boring animation stuff. I will cover animations and things in probably a different video. Right, with our animations set up and ready, we should be able to hit Control S to save, go back into the game and see how this runs. So we're playing our idle animation, our running animation, our jumping animation, and our falling animation. Perfect. Now, this is the complete setup of a intermediate platform controller. The next video will be covering finite state machines, coyote time, more complex movement, different types of states, and different types of, I don't know, we'll move into it, like things like attacking, rolling, crouching, dashing, all of those fun things. So if you really want to kind of figure out how to do something a lot more complex than this, make sure to subscribe, comment, tell me if you are having issues or if there is something you would like to see. So thank you for watching, and I will see you in the next video.